Yes, sir. Big 2 practice assignment problem number 13.
Yeah. Wait a minute. I just open it. Mm, yes, my screen is visible. Week 2 practice assignment.
Yes, sir.
Problem number.
13.
Okay. So the number is 0 1 1 0 1 0. I think so. Yeah. So can you tell me, this is the binary? This is the basically positive number or negative number?
Positive, sir.
Positive number. How we define that it is a positive number?
Because its MSB is starting with 0.
MSB starting with 0. Okay. So the question is, if the 2's complementary representation of a given number is okay. So it is already 2's complement. Okay. So now we have to again convert into the original number. Okay. So 0 1 1 0 0 1. Okay. And
Sir, why we convert, sir?
because it shows that it is a 2's complement number.
Yes, sir. The
Whether the
number
number is
which is
positive or
already,
negative, either the number is positive or negative, we have to convert into the 2's complement.
sir, if the
Because
number is positive, sir, then why we take 2 complement of it?
like for example, we have a mm, like what is the 2's complement of plus 7?
That is equal to 1 1 1 0 1 1 1.
0 1 1 1. Okay.
Yes, sir.
If I say it is a sine number, and that is a particularly 2 7 plus 7. Okay. Now if I take the
Yes,
2's complement, so just sine number should be as it is. I take the complement of this one. Okay, so we start with the from the. mm, I think you are aware that if n bit number is available, so what is the maximum and minimum limit? The maximum limit is from -8 to +7.
yes, sir.
Okay, so can you tell me how can I represent the -8 to +7? So -8, -7, -6, -5, -4, -3, -2, -1 becomes 0. Okay,
Minus, yes, sir.
so what is the -8?
16 minus 8, that is equal to 1 1 1 1.
1 1 1 1.
Yes, sir.
How?
No, sir, no. This is 5 1, sir, 5 1.
5 1, but it is a 4-bit number, no? So 5 ones is not possible. So what should I do? I just write a number 8, okay, and take a 1's complement, 2's complement of this one. So it is also a number of -8.
Yes, sir.
Okay. Similarly, if I go with the -1, okay, take a complement, so it becomes 1001. This is the number. Okay. Similarly, if I talk
Sir,
about yeah,
sir, 1 1 0 0, it is a -1 representation. Cause if we multiply
1001,
MSB
1001.
8 minus 1, that is equal to -7. If we multiply -1 with 2 to the power 3, then
Okay,
it
you are
become
saying that
-8.
-1 represented as a 2 raised to power 3 minus 2008 -9. It should be the -1. Okay.
Sir, can you convert the 1001
Sorry,
into the
sorry. It is a
decimal form?
yeah 10.
1001 into decimal form?
It is a 9.
It's a 9. Yeah. Then you,
2 raised to power 3 minus 9 becomes -1.
sir, that is equal to 1001 equal to 9. That's right. But why you mind subtracting with 2 to the power -3?
That
Because the
is
number is a
a
4 bit.
okay. Uh, okay, so leave that particular concept. One is what is one? Sorry. Wait a minute. What is one is
-1.
0001. Okay, and if I take a minus, so I take the two's complement, so it becomes a 1110.
Yes, sir.
Okay, so it becomes a -1. Now similarly, if I am taking the 7, so 7 should be represented as a 111. Can I take a complement of this one, so it becomes a 1 two's complement 00, and the sign bit should be
Sir,
0.
sir, -1 equal to 1111, sir. 4 1. If you write 1110, then it's
Oh,
one
sorry,
complemented form.
1111. Yeah.
Yes, sir.
Okay. Now the 7 number is 0111. Okay. It is a positive number, so we
Yes, sir.
can't take the two's complement.
Yes, sir.
Okay. Now the thing is that I just mentioned that 0111 given. Okay. And that particular number will be given in a two's complement.
Yeah.
Hmm. Okay.
Yes, sir.
Uh, yeah. Now, if I want to extend the limit, like this is a 4-bit number, if I want to extend the limit, so I just want to convert this 4-bit number into the 8-bit number. So what should I do?
Add 4.
Is it fine?
Sir, if you add 4 ones before 0, then the whole number will be changed, sir.
Whole number will be changed.
Yes, sir. If you write 1110 011, then it represents something different.
Okay. So can I represent as a this one? If
Then
it is a
this
negative
become a
number,
yes, sir. This
minus,
represent negative number.
this represent a negative number. Okay.
Yes, sir.
So similarly, what we do in this question number 6 is uh, this number already given is a two's complement number. We
Yes,
don't
sir.
calculate the 2's complement of this one. This number is given a 2's complement number, or any hexadecimal, any number is there. We have to convert that number into the binary form and take the 2's complement, and that 2's complement number is this one.
Yes, sir.
Okay, the question is this one. What is the question? Any x number is there in a decimal. First of all, we convert that number into the binary, and then we convert this particular number in the 2's complement. And that number is 0, 1, 1, 0, 1, 0. Okay.
Yes, sir.
Now, if I go back to the previous one,
Binary form.
we have to take a 2's complement first to convert into the
Why?
binary form,
Why, sir?
because binary number is there and we have to take the 2's complement. After that, this 2's complement, because we don't know the number is positive or negative.
Sir, but here the MSB represent that the number is positive because MSB is 0.
MSB 0, but after 2's complement, it becomes 0, no?
That's why, sir, this is a positive number because the after taking the two complement, the MSB is 0, then the number is positive.
If I take, yeah. If I extend the limit of this one, like I extend the limit of this one as a 0, 1. Now, any
Then,
change
sir,
in the
then
number?
this number, yes, then this number is a negative number.
This
We
number is
have
a
to first
negative
take two
number.
complement.
Okay. Now we have to take the 2's complement.
Yes, sir.
What is the 2's complement?
Mm.
0, 1, 1, 0, 0, 1, 1, 0. No, this is not a 0, 1. Yeah, one more concept. If you remember that if we extend the MSB in 2's complement form, so what is the best way?
If the number is negative,
Like
then
4-bit number is available. Okay. If I want to convert this 4-bit number into the 8-bit number, what should I do in 2's complement? I just add a 1, 1, 1, 1.
yes, sir.
Okay. Why we add the
Extend
1,
the
1,
base.
1? Because we are taking 2's complement, so this 1 becomes 0. Okay. You remember that particularly concept or not?
Yes, sir. Yes, sir.
Okay. So the similar thing is that if the number is 6-bit number, so it is a 2's complement number. So what should I add? I added 2 ones to convert into the pure hexadecimal form.
Sir, sir, bit extension is a we extend the bit of MSB, sir.
Yeah,
If
we
the
extend the
MSB
bit.
is 1, then we add 1. Then if MSB is 0, then we add 0.
Okay. So if this is a 2's complement number,
Yes, sir.
if it is a 2's complement number, I am taking that initially it is a 1. Okay. And
Okay.
this is the number I take the 2's complement of this one. So it becomes, sorry, not this one. I just take a 1, 0, 0, 1, 0, 1, 1, 0. Okay, this is the number. I take a 2's complement of this one. So I am getting a 0, 1, 0, 1, 1, 0. Okay. So initially the number is this one. So I just extend this 2 bit.
Okay, sir.
Okay. So now we extend the 2 bit 1, 1, 0, 1, 1, 0, 1, 0. Now take a 2's complement of that one. Initially we extend the bit and then take a 2's complement. So it become a 1, 0, 1, 0. 0 1 0 0. Now
Yes.
group of 4, sorry, it is a 1 and 0. Group of 4, it becomes 2 and 6. Already we are taking the 2's complement. Na? The point is this.
Sir, can you repeat, sir, what you did? I didn't get
Okay.
after this point.
Yeah. After this point, we extend the limit first of all. So 1 1 0 1 1 0 1 0.
Sir, the number given is 0 1 1 0 1 0. You take it to complement of that.
0 1 1 0 1 0.
Yes, sir, this is the number.
Okay. Now, if what is the value this one? 2 8 16. 16 plus 8 plus 2 is 26. Okay. Now what is the possible number? Is 2 raised to power 6. Okay, the answer is 26.
Yes, sir. I got one A, sir.
Yeah. Okay, so if I extend it to raised to power 5 minus, and if I directly taken that one, because it is a 0 already there. Okay, 0 already there. So what is the number of that one is 26.
Yes, sir.
In the decimal point. And if I convert into the hexadecimal, so 0 0 0 1 1 0 1 0. So it is a 1A. You are saying it is a 1A.
Yes, sir.
So this is the correct one. Correct answer.
Okay, sir.
64 minus 26. No, that is 38. You can take, okay, this is a 26 also in hexadecimal. You can do in this way also. I think you know this formula. If n bit is given, okay. So what is the decimal equivalent of this number is 2 raised to power n minus decimal number. You know this method?
No, sir. I listen it about first time.
Okay. Basically, like if we say that 0 1 1 0 1 0 is there. So what is the decimal number of this one?
Mm.
26.
Yes, sir. 26.
Okay. So the value of n is 2 raised to power 6 minus 26. So that is 38 in decimal. Okay. Now if I convert 38 into the decimal, into the hexadecimal, so what should I do? I just take a division method by 16. So 16 to the 32, remaining is 6. What is the answer? 26 raised to power 16.
Then the decimal conversion are different, sir, because if you convert the same number with the decimal, that is 26, and if you use that formula, you get 38.
Yeah, it is a 2's complement. If I represent it into the 2's complement, so it is a become 2a. Like for example, I am just taking that. If I want to represent a 8, okay. So for the representation of 8, how many digits are required? 4 digit, 4 bit is required.
Yes, yes, sir.
So
In two complement, we need 4 bit.
yeah, in the 2's complement we require the 4 bit. Now can I, so 2 raised to power 16, what should I minus with that? So it become a minus 8. It become a 8, not minus 8, it become a 8. So 2
Yes,
raised to power 4 minus 8, if I divide, if I minus 8, so it becomes equal to the 8. Okay.
yes, sir. Yes, sir.
Now you can represent the value of 8 in the decimal, sorry, binary number. So it is equivalent to the minus 8 raised to power 10 is equal to this one. Similarly, if I
Sir,
want to
this is
represent a minus 6, if I want to represent a minus 6, so 2 raised to power 4 minus x. So what is the value of x?
x is equal to
10.
yes, sir, 10.
So if I represent the 10 in the binary number, so it is a 1010. So minus 6 is equal to 1010. You can check that one. Okay. First of all, we represent the 6, 0, 1, 1, 0. Then take as 2's complement. So 0, 1, 0, 1. It is a minus 6.
Yes, sir.
Okay.
Ultimately, you taken the two complements, sir.
Yeah, I am
That
taking
this
2's complement.
this 30 this 38 is a two complemented form.
Yeah, 38 is a 2's complement form. Because already it is given a 2's complement number. Na? The question, if I say that the question is somehow it is not a correct way, we are saying that it is not a correct way, because if it is a higher MSB is 0, so the number is similar. The number is similar. But I think it will be the taken from the previous term. I have not checked that particularly. Okay.
Yes, sir. Then which answer could be correct, sir? Either 26 or 1A.
If I say that the 1A should be the correct one, if I go logically, so 1A should be the correct one. Okay,
Okay,
but
sir.
it mentioned the 26.
Okay, sir.
Okay. Any other doubt?
Sir, week 4 graded assignment, problem number 5, sir.
Week 4 graded assignment. Problem number 5. Yes. Okay, so I will write it here. With the problem first question, x is equal to 0. So x bar y dot z plus x XOR y z bar is equal to 1. Okay, so if x is 0, so x bar is 1. Okay, so this particular term is simply y z. Clear?
Sir.
Now second term is that this is the XOR gate. Now what is the truth table of XOR gate? X, Y and output. So what is the truth table? This is a 0 0 0 1 1 1 0 and 1 1. So output is 0 1 1 0. If I create a concept, so this 0 if I take a constant, so when I giving the second input, similar output we are getting. Okay, the second input we are getting the similar output. Second input we are getting a similar output. So we can say that if any of the input is 0, that means one input is fixed. Okay, so the output is just similar to the opposite one. That second particularly output is just similar to the second input. If second input is 0, output is 0. If second input is 1, output is 1. So that means if any input is 0, so this particularly XOR gate will be behave as a buffer. Okay,
Yes, sir.
so I just say that it is a Y and it is a Z bar.
Yes, sir.
Okay, now can I open this equation? So it become a Y bar Z bar plus YZ plus YZ bar. Okay, can I take a Y as a common?
Yes, sir.
So it is a Z plus Z bar. So it becomes a 1. Okay, and Y plus Y bar Z bar. So it becomes Y plus Z bar. Okay, clear?
Yes, sir.
So that means Y is 1, Z becomes 0. In both situation output is 1. 1 point is this one. Okay, if we go from here, if I go from here, so either Y dot Z becomes 1 or Y Z bar becomes 1. Okay, then output is 1. If this condition is true, that means this particular situation. But when this condition is true, this condition is true when Y is equal to Z. Can I repeat it again?
Yes, sir.
Okay. So basically thing is that we get two terms. One is the Y X nor Z plus Y Z bar. Okay.
Yes, sir.
If I and that particularly output is 1, either Y X nor Z should be 1 or Y Z bar should be 1. Either this or
Yes.
this.
Yes, sir.
Okay. Now if I take that if this particularly condition will be true, so that means the Y should be equal to the Z. Because in the XNOR gate, what will be the output? Output is 1 when both input are same. Output is 0 when both input are different. Okay. And
Yes,
if
sir.
I consider this situation, so what is the output? That if Y is 1 and Z is 0, then output is 1. So we are getting two particularly condition. We are getting two particularly condition. One is the y is equal to z, and second is the y is equal to 1 and z is equal to 0. Or we can say the y is equal to z bar.
Yes, sir.
That is equal to 1. Okay. First condition y is equal to z. Second condition y is equal to z bar is equal to 1. Now check what is the output. So the first condition is y is equal to z. Okay. The second one is y is equal to z is equal to 0. And third one is y also z bar. Y is equal to z bar. But that is also equal to the 1. Okay.
Y equal to Z bar equal to 1.
Yeah, that is it. Because if y we are consider the y is equal to z bar, so this term doesn't give you 1 when y is equal to 0 and z is equal to 1. Then this term gives the output 0.
Yes. Got it, sir.
Clear?
But sir, it seems like contradictory, sir. One equation is giving y equal to z equal
Yeah.
to 0 and y equal to z equal to 1, and other condition is giving y equal to z bar equal to 1. It seems
Mhm.
like contradictory.
Yeah, it is a contradictory. So we have to take the two conditions now. So we can say that either z value is 0 or z value is 1. In both cases, output is 1. But y should be always 1. Okay. If I say y is equal to z, so it is applicable when y is equal to 1, z is equal to 1. It is applicable when y is equal to 0, z is equal to 0. And if I am taking the third condition also, so y is equal to 1, z is equal to 0. Okay. So if I consider these two conditions, so I can say y is equal to 1, z is don't care. And if I consider these two equations, so I can say y is equal to don't care and z is equal to 1. Sorry, z is equal to 0. So in the both situation, the output should be 1. Okay.
Yes, sir, got it. And sir, can we apply this logic also for or get anyone get is 1, then output should be 1. Then
Yeah.
instead of checking what to get, we will check any one get.
So either we can check this one is 1 or we can check say that this one is 1.
Yes, sir.
Okay.
And yes, sir. Then suppose we check the second one, then we get y equal to z bar equal to 1.
Yeah. Y is equal to z bar is equal to 1.
Yes,
If
sir.
it is mentioned that y is equal to only z bar, but the value is either 0 or 1, if it is not mentioned, if this term is not mentioned, we can't say that this condition is true. This condition is false.
Yes, sir. Then sir, this option doesn't match. I didn't tick anyone.
Mm,
Then the OR gate should be here. OR gate one condition of OR gate get false, sir.
yeah.
Then
Okay.
sir,
Like for example, if we say that y is equal to z bar, only this condition is say only this condition. But what is the value of y? It is not mentioned. So we can't say that this condition is also true. Till y value is 1, this condition is false. Clear? Yeah, now clear?
yes, sir, got it now. Means if any logic of OR gate is getting false, then we have to check
If
another logic.
yeah, we have to check another logic. Like for example, in mathematics, you see that if x minus 2 and x minus 3 becomes 0. So what is the root of what is the value of x is possible? So what we do, we are
Hmm.
taking one condition is x is equal to 2, x minus 2 is 0, and second condition we are saying that x minus 3 becomes 0. So from that one we are getting the x is equal to 2 and 3.
Yes, sir. Yes,
Okay.
sir.
So we have to consider
Okay, sir.
both conditions. Similarly, in this particular part, we are also doing the same thing. we have to check two particularly condition. One is either one term is 1 or second term is 1. If any of the term will be 1, the output is 1. So we can take the both conditions.
It is preferable to take both condition equal to 1.
Mm,
Because if we take one condition equal to 1 and 0, then I might we get wrong answer.
why?
Because sir, you taken that y x naught z equal to 1 and y z bar equal to 0, then you get correct answer y equal to
Yeah,
z. And
yeah.
then if you take that condition y x naught equal to 0 and y z bar equal to 1, then you get
The
the
output is
different
1.
logic.
Either this one is 1 and this one is 0.
Uh, Yes, sir.
Or this one is 0, this one is 1. Or this
Yes,
one
sir.
is 1 and this one is 1.
So then we suppose we check the middle one condition 0 plus 1.
0 plus 1, okay. So in this scenario, what we say that y is equal to z bar and both are 1.
Yes, sir.
Okay. Now if you see the option, this option is not available. Only y is equal to z bar is available option mein. In option, y is equal to z bar is available, but y is equal to z bar is equal to 1 is not available.
Yes, sir.
Then we can't pick this particularly second option.
Yeah, means by checking the one option, we can't get the full
Yeah.
full answer.
Yes.
We have
Yes.
to check all three. Either eh,
That is.
okay, sir.
Yeah. Any other questions? Hmm. Grade assignment 3, question number 13. Sir, I request you to upload a solution of graded assignment of week 3 and week 4 few days before. I think we have uploaded the graded assignment solution 3 and 4 is uploaded or not?
No, sir. Even the practice assignment solutions for 3, 4 have not been uploaded, sir.
Okay. So I will do that. Okay. I think I just upload that one, but the question graded assignment 3, question number 13. Yeah. In a circuit, when a 2-input AND gate is replaced by a 2-input NOR gate and vice versa, select 3-bit input representation as a decimal number that asserts the output y is equal to 1. Okay. So what you have to do is that
We have to take reference from upper circuit, sir. The problem number 2 with circuit given.
so we have to convert the and okay, just take if it is possible copy. Okay, this is my circuit. Now what I have to do, I have to convert a 2-input AND gate and replace with 2-input NOR gate. So this is the AND gate, this is the NOR gate. So I have to replace these two. So A, B, A, B, that NOR gate C X NOR gate Y. Okay, so here I am getting the A B bar A B. Okay, if I put into the NOR gate, so it is a B bar plus A B whole bar. So it becomes a B dot A B bar. Okay, so it is a B dot, if I break it as a bar plus B bar, so it is a B A bar plus A B B bar, that both are 0. So this will become 0. Okay, now it is an XNOR gate. So in the XNOR gate, what is the output? If one input is A, B and output. So what is the two tables? 0 0 0 1 1 0 and 1 1 1 0 0 1. If any of the input is 0, if any of the input is 0, we are getting just complement output. Okay, if any of the input is 0, we are getting a complement. If any of the input is 0, we are getting a complement. Okay, so this one is the 0, this one is the C. So what we are getting? We are getting a C bar. Clear?
Yes, sir.
Now what is the select the 3-bit input representation as A, MSB, B and C, LSB in the decimal number that assert the output Y is equal to 1. So 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and 1 1 1. If we are talking about the output, so the output is what? Can I solve it with the? I just go with the gate 1, gate 2, gate 3, and gate 4. 1, 2, 3, and 4. So AB bar. So if A, B, C, so it becomes 0 0. So output is 1. 0 0. Output is 1. 0 0 0 0 0 and 0. Okay, in the gate 2, these two output is 1. Both are 0. In the gate of XNOR gate, 1 1 1 1 0 0 0 0. That is fine. Yeah. Okay. Now with respect to C, so 0 and 0 XNOR is 1. 0 1 XNOR is 0. 0 1 XNOR is 0. 1 0 1 1 0. Select the 3-bit input representation as MSB in the decimal number that assert the output is Y is 1. 0 1 2 3 4 5 6 and 7. So 0 3 5 and 6. Is there any mistake? This is the NAND.
Sir, instead of writing the whole truth table, we can simplify the equation, sir,
That is
and go and got the value of ABC.
the equation is one equation is a b bar, second equation is ab, and that is plus. Oh, sorry, we have done one mistake. Yeah, here we have done one mistake. No, that's fine. It is a ab bar, that is a ab. We are taking that a NOR gate. Okay,
Yes, sir,
and
the simplification.
it will be the XNOR with C. Yeah.
Where
So
you get, sir, AB whole var dot AB var, then this is possible for all value of A and B. And because X var dot X is equal to 0, sir.
X dot X bar is 0. So
Yes, sir.
okay, so you are solving this one. So it becomes a 0. So it becomes a 1.
This, sir, that this
X
equation,
plus
not, sir,
X
that
bar,
equation that you, yes, sir.
X plus X bar is 1.
So, don't, sir, plus, not plus, sir, that you written down, sir, that equation AB whole var dot AB, sir. After simplifying that, this we got now that AB dot AB whole var.
AB dot AB whole
Yes,
bar.
sir. Yes,
This one.
yes, sir, this one, sir.
So this is 0.
Yes, sir.
0
Then
XOR with
be
C
0.
is 0 XOR C with the C bar.
For getting one as a output, then C must be 0, sir. Because for XNOR gate, we get one when both input are same. Then
Yeah.
one input is 0, then C must be 0.
So Y is 1 when C is 0.
Yes, sir. And
Okay.
X dot X bar is possible for any value of A and B.
So C is 0 here. So output Y is 1. C is 0 here, output is 1. C is 0 here, output is 1. And C is 0, output is 1. So
Yes,
basically
sir.
at 0, 2, 4, and 6.
And 6. Yes, sir.
So these are the 4 possible positions where the output is 1. Okay, now the question is what? The question is, yeah. So it is given the 1, 2, 3, 4. So 2 and 4 is the answer. 2 and 4 is the answer.
Sir, what MSB and LSB saying here?
Uh-huh. The MSB and LSB saying here is that if I represent, like for example, I just see that if I change that sequence CAB, we are getting Y is what? C bar. Okay.
Yes.
And if I say that this is the combination 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. Like this is the sequence. We have not mentioned that which one is the LSB and this one is the MSB. Okay, C, B, and A. C, B, and A. Now what is the output? The output is 1, 1, 1, 1, 0, 0, 0, 0. Okay. Now
Yes.
when the output is 1, when 0 decimal number, 1 decimal number, 2 decimal number, or 3 decimal number. On these 3 positions, my output will be 1. Now if I change the order, I just say that A is the MSB, C is the mid, and B is the LSB. So the representation is 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. Now what is the output? Output Y is C bar. So when C is 0, output is 1. So 1, 1, 0, 0, 1, 1, 1, 1. Now, sorry, 1, 1, 0, 0. So now what is the output? Y is 1 when the decimal number is 0, 1, 4 and 5. Okay. So if you change the order of the A, B, C, so your decimal value will be also changed. So that's why for any confusion we mention that A is the MSB and C is the LSB part.
Okay, sir.
Okay. Yes, any other question?
Sir, I had a questions related to graded assignment of week 5. Questions actually. Questions related to the questions of week 5.
Questions related to the question of week 5.
Yes, sir.
Okay, so that I just tell you in previous class that I will share some K-map questions. You are asking about that one?
Sir, I had some queries related to question number 3, 4, and 10.
Okay. So graded assignment 5.
Yes, sir.
Okay. Yes.
Sir, with respect to question number 3, we what we are looking for is the possible combinations, right? It's not a single combination because there are different ways in which we can form the groups. So it's
Okay.
asking for all the combinations that are valid.
Okay. So if I create a one combination is this one and one combination is this one.
Sir, POS groups.
Oh, sorry, POS. Mm. So in the POS, one group is this one and one group is this one.
Yes, sir. So that eliminates all the this thing. We get one equation, one equation related to this, but there is another equation in this which is also equivalent, which we can get
Wait a
by
minute, wait
solving
a
other.
minute, wait a minute, wait a minute. I just do that one. So if I go with this one, so the value is B plus C. Second is
A bar plus B.
A bar plus B bar. Okay. This is the one valid solution. Okay.
Yes,
Along with that one, you can create one more group.
right, sir.
Okay. That particularly group is called the, we can say that this particular term is redundant term.
Okay. So this is the minimum viable thing, and the other one is has
Okay,
an
redundant
extra.
term. What is the meaning of redundant term is that if we can create a one more group, doesn't mean that this all POS max term will be included in that one or not. We are including one more redundant term. So why we use this redundant term, we will discuss this particularly thing is when we are discuss about the hazards. I think that is not covered in week 5. Hazards.
No,
Hazard
sir.
is basically what will be happen is that when we provide some signal to any of the gate, okay, so the gate will be taking some delay.
Okay. Yes,
Okay,
sir.
like for example, I just say that I am taking one is the AND gate A and B, and one is the OR gate A and C. Okay, so what it will be taking the 2 nanosecond time delay and it will be taking the 5 nanosecond time delay. Or basically, we are saying that it will be taking the 5 nanosecond time delay and it will be taking the 2 nanosecond time delay. Okay,
Okay.
so after 2 nanosecond, and these two particularly again apply into the AND gate. So after 2 nanosecond, we are getting particularly output at this point. We
Right.
are getting this is the correct output.
Right.
Okay, but the problem is that at this point, this output is considered as a don't care. Why? Because it is not a genuine output.
Okay, because it is larger than 2 nanoseconds.
Yeah, after 5 nanosecond, it will be the correct output. But
Okay.
before 5 second, it will be the don't care condition. That means any particularly input that is available, previously available in A and B, 5 second below, before it is available A and B, we according to this one, the AND gate output will be given.
Okay.
Okay, so
Okay, sir.
particularly to avoid this condition, there is some hazard condition is available. Now, if I say that A is 0, A1 and B is 0, 1 0, so what is the output? 1 0, and we are getting a 0. Okay,
Right, sir.
but after 2 nanosecond, what we are considering that initially it will be the output as between 2 to 5 seconds. 2 to 5 seconds, the output at this position is 1.
Okay.
So one output is 1, second output is also 1, and after 5 nanosecond it becomes 0. So we are getting a actual output. I just draw this one. One output is always 1. One output is from 2 to 5 nanosecond it becomes 1, and after 5 nanosecond it becomes 0. Why? Because A value is 1 and B value is 0. So what is the final output Y? In the final output Y is basically 2 to 5 second it becomes 1, because the don't care condition of AND gate. And why this don't care AND condition? Because it is taking the time delay greater than 2 nanosecond. Okay, and after that we are getting a correct output. So this output is the correct, and this particularly case situation is called the hazard. This is the unwanted.
Okay, sir.
Okay, to avoid this one, what we do, we are adding this resultant, so that this particularly delay will be increased. That the particularly 2 nanosecond delay will be taken by them. Okay, so if we add one more gate here, and this particularly gate will be taking some particularly delay,
Okay, so buffer kind of.
5 nanosecond. So we are getting a correct output at 7 nanosecond here and 7 nanosecond here.
Okay.
Okay, to avoid this particularly hazard condition, that is the unwanted or basically the not matching output. So we
Okay.
include this term also.
Okay, sir. So what we are learning till now is the ideal
Yeah, that
condition.
is the minimum possible mean term or max term.
Okay.
Okay,
Okay, sir.
we are excluding the hazard term. Like for example, if I say that, like this is the case. Okay, if I am taking that as a max term, so one group is there, this one.
Yes.
One group is there, this one. Two groups is the best.
Right.
Okay, but along with that, if I create a one more group, that group is not a required group. Why not required? Because already without this group, all max term will mean term will be covered.
Right. And it also increases the number of gates.
If it also increase the number of gate, but it is required only to remove this hazard condition.
Okay.
Okay,
Okay.
so if
Okay.
we are considering this one, it only remove the hazard. If we are not considering this one, there is no issue, there is no particularly change in the output, because all mean term already covered.
Okay, sir. Okay.
Okay.
Okay, sir. Sir, in question number 4,
Mm-hmm.
the number of sum terms that it is asking is the POS product of sum terms, right?
Yeah.
Okay. And sir, one more thing is like
No, product of sum is sum of product term.
sum of product terms.
Mm-hmm. Mean term is given, na?
Okay. Okay. Okay, sir. Sir, and when we convert this, this is the min term. We are converting it to a max term. Then in that situation, the don't care conditions remain the same, right?
What? Yeah, Don't care condition, no effect in the don't care condition.
Okay. Okay, sir. And sir, related to question number 10,
Mhm.
which is about the NAND gates.
Mhm. You have to do that one. After particularly deadline, we will do that.
Yeah, sir. What I wanted to ask is, in the question, um like the first question number 10, it
Mhm.
is saying minimum now, like the question says implement the simplified Boolean expression using 2 input NAND gates and 3 input NAND gates.
Yeah.
Now, for question number 10, it says minimum number of NAND gates is R. Now, in this question, it is asking that we use only 2 input AND
Two
gates
input
for.
NAND gate. Yeah, yeah. You see that one in the question. Two input NAND gate. It will be represented as the NAND two. In the bracket, it is represented as a NAND two. And three input NAND gate. It is represented as a NAND three. So what is the meaning of NAND two? That is meaning is the two input NAND gate.
So in question number 10, only 2 input NAND gates have to be used.
Yeah, yeah, yeah.
And in question number 3, question number
Yeah.
11,
Three
only
input NAND
three,
gate. Only
only
three
three
input.
input.
Only
Okay.
three input NAND gate will be used.
So it's not a combination of NAND 2 and NAND 3 gates
No,
that we
no,
have to use.
no, 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 no.
Okay, sir. Okay, sir. Okay, sir. Thank you so much. Sir, and please, for weeks 3 and 4, please upload the
Hmm.
uh, practice assignments and the graded assignment solutions, please.
Yeah, sure.
Thank you, sir.
Yeah, I will upload that one. Sonali, okay. So,
Sir, and
yeah.
I asked you, sir, problem number 9, sir.
in
I sended you solution, sir,
in question
GS space.
uh, problem number 9, week 5.
I got the answer, sir, but my doubt is
Just check that one. What you are
that
doing?
that SOP.
Hmm.
What, sir?
I will check that one.
Okay, okay.
So, now we have one more session. I think revision. Yeah, I will do that. Surya Prakash, I will already tell. I will upload the graded assignment solution 3 and 4. So on Friday we have one more revision session. So if you have one other doubts related to the week 1, 2, 3, 4, you can ask. Okay. So thank you all.
Thank you, sir.
Yeah.
Thank you, sir.
So this YouTube link. I think when you go in the particularly channel link is already available with you. When you go with the channel, you can see all the recorded live session recordings. Anyone have the YouTube link channel? Okay. So already someone shared. So yes, you can check in chat box. Surya Prakash. Okay. So thank you all.